Hello, everyone. Welcome to Can.Do.So. Today, we are going to uh, enter to the new step to start the data analysis. And first, we are going to show you. I'm going to show you the normal distribution, which is the most important distribution in this statistics and the data analysis. So let's get started. So from the previous lessons, we have learned how to use R to do some basic data analysis. And from this lesson on, we'll start to learn how to use R to analyze data. So it's, this is the real purpose of this series of this course. First, we know the packages we will use in this lesson. And so why data analysis? Because data analysis is a process of collecting, cleaning, and analyzing data to discover useful information, so conclusions and support decision making. As a researchers, we we will spend a lot of times to deal with data. They're saying that when you write a paper, you spend 20% times to write paper and 80% times to deal with the data. So if we can improve our efficiency of data analysis, I think that will extremely improve your working on researches. So we will use some examples to show why data analysis is important and useful. Because first, it will make it easier and more accurate for us to understand many things. Let's start from an example. How do we describe the economic well-being of a country, for example? So we might have a lot of ways to describe, like what the people in this country eat, how they live, how they dress, how they travel. But the data might be the simplest and the accurate way to describe it. And the best data may be the GDP per capita, which is an average data. It's the total GDP. GDP is a gross domestic product of the country and divided by population of the country. So this is the average data. More generally, we can use this formula uh, to describe to get the mean or average. And we can use R function to calculate mean easily. So this is a gapminder is a data, and we have used a filter, which is we just need 2007, and summarized this. All of this we have covered. If you don't feel comfortable with these functions, you can go to the previous course and to watch it and practice it. So we use the average GDP PPC, and with mean, this is a function to get the average data of the data, and this we arrange it from high to low. So this is the 5 continents, the average GDP per capita. So this is the mean in R, mean function in R. So normally we just want to get a rough idea about the country's well-being, economic well-being, but that's not enough. It's a good measure, but it's not enough. For example, how many people earn the average salary and how many people earn less or more than the average salary level. and how far away from low or high to the average level. So that this is where we need the distribution of the data. So again, we can use our function to tell us the distribution of the data. In previous, we have covered some kind of functions. Here we can review it. Summary will tell us the minimum data, maximum data, and first quarter, and median, mean, and the third quarter. Minimum, maximum is easy to understand. Median is, which means in this number, half of a population earns okay, half of a country's GDP per capita is less than this level, and half of country is greater than this level, and this one is which means 25% country lower than this level, and the third one is 25% the GDP per capita is greater than this level. So mean we understand that we add all the GDP per capita and divide it by the number of countries. So this is a distribution. Okay, we can use it. We can use a histogram to describe the distribution of the data. Okay, and this is a box plot. Box plot we also have covered in this way. So here is the mean. This line is the mean. Oh, not mean, median. Excuse me. It's median, not mean. And in this part is the from the first quarter to second to the median, and this is from median to the third quarter, and this one is the fourth quarter, and this one is this first quarter. But what does the dot means? The dot means means outliers. You see this one, this part is 1.5 times of this part. So if there are still some some data is greater than this part, because this part goes as far as 1.5 times to this bytes. So if there are some extremely bigger one and or extremely smaller one data, it will be as data as should as outliers. So we can see that in this country, it's in Americas, the GDP per capita is extremely divided from the not equally, not, and this one African is also, but in Asia, European, and Oceania, there is not much outliers, so more equally. But why data distribution matters? We can use a example to understand why data distribution matters. Suppose you are a seller of some kind of adult's shoes. How many shoes should you buy for your stock? Suppose there are 10 different sizes, and should you buy each size equally? If not, which size should we buy more and which should we buy less? So I guess you would be in trouble if you buy each size equal number, because you will find that some sizes are sold out quickly, while some sizes are sold only a few, even maybe some very extremely sizes nobody even asked. So before you get your stock, you need to know the distribution of the size of potential customers. Then you can prepare the inventory according to the distribution. Okay, then why normal distribution? Why normal distribution matters? Because we can still use previous examples. You will find out that in most cases, the bigger or the smaller the sizes, the fewer they are sold. Because the shoe size of adults is normally distributed. And normal distribution is the most important distribution in statistics. It is called normal distribution because it clearly shows us that the normal level of the data is the most frequent level. In previous example, we would stock more shoes of the most frequent size. And in normal distribution, the most frequent size is average size. It is called normal distribution also because it is the most common distribution in nature. For example, the height of people, the salary of employees, exam score of students, even the length of the tail of a dog. So, so that's why it's very useful. And even some data is not normally distributed. We can still use normal distribution because of the central limit theorem, which will be discussed in part 2. Okay, let's take a look at the features of normal distribution. Normal distribution is a bell-shaped curve, just like this bell. It's a bell-shaped curve. And the mean, median, and mode, which means the most frequent numbers, data of normal distribution are equal. And not only equal, and they are actually is at the center of the curve. It's the center. So, and also the curve is symmetrically distributed around the mean, around this, also the mode and the median. So the two sides are the shape and the area under the curve are equal, the both sides, this sides and this sides. This side is below the mean, and this side is greater than mean. And the total area under the curve is 1 because we use this one to measure the probability of each data's frequency. So so we know if it's a probability, so the add together must have to be the 1, which means 100%. Yeah, this is curve. This is area under the curve, which I show in blue size, in blue color. And the curve is defined by 2 parameters, mean and standard deviation. So the mean we have showed is this a standard deviation. This is a standard deviation is formula. And the mean determines the location of the center of the curve. You see this red one is mean is 0, and the red one means 0, and the green one it means -2, and the blue one is 2. But the curve's shape and the height of the curve, it's equal. The only difference is their mean is different. There. So that's the mean just means the shape is in this way, in located here, located here. And also the standard deviation will determine the width of the curve. So the green one is standard deviation is very small, which means they are located very close to the central. And standard deviation one is normal, is like this one. Great. And if standard deviation is bigger, then it will it will shorter and it will wider. So see the difference, different standard deviation. Standard deviation, which means the data is how far away from the center, how far away. Yeah. And we can see the data y axis is the value of the data. So this is -5 and 5, and the y-axis is the frequency of the data, which means if this -5, its frequency will be this one. If the frequency is 0, the frequency value is 0, and the frequency will be higher, which is 0.54. Okay. We have PDF and CDF. PDF means what? PDF means formula of normal distribution is the curve of the line, which means PDF is standard. This is line of the curve. We know that any curve, any line, we can use a formula to denote. For example, this one is roughly a y to x, and this one we can y roughly x to x squared. But this one is we use this looks a complicated formula to show this line. And this CDF, which means the error under the curve, error under the curve. So from this is an integer formula, which is convenient to find the area of the shape. So x is if x equals to for example 165, then fx, which means is we find this part of the to the left of the curve, under the curve of the area under the curve up to the left of this line. And if x is 170, then it's this part. If it's 175, then it's this part. So it's also always is to the left of this value. Okay, and this is this first part of this this course, and the next part I will show you how to use R to calculate the probability of normal distribution, and more. Okay, I hope this is useful for you, and you can get a clear understanding of the zero part of the normal distribution. And if you have any questions, you can go to the slides, which I will put the link below, and you can watch read the slides. And if you still have any questions and you are not clear with some part, I can respond to you. Just leave a message below. Okay. Thank you, and see you next time.